Hi, everyone, and welcome to our discussion about ionic bonding. So today we want to talk about ions and how they bond together. So the question that comes up right away is, what does ionic bonding have to do with piracy? Well, stealing, of course, right? Ionic bonding is all about stealing electrons from one another, and that's what we want to get into today for it. So first, definition for an ionic bond. It's basically an attraction between two ions that are oppositely charged, right? So if it's an ion, it's not neutrally charged. It's either positive or it's negative. It's either gained electrons, so it's negative, or it's lost some electrons, so it's positively charged. So a great example of that could be salt, right? Good old sodium chloride, right? The sodium atom has lost electrons, so it becomes positively charged. The chlorine atom gains electrons, so it's negatively charged. Kind of like in this short little animation right here. You can see the sodium atom over here, right? The sodium atom, let's see here you go. It has one little electron that gets pulled away to the chlorine atom. The chlorine atom becomes negative, the sodium atom becomes positive, and that negative positive reaction, that's what actually draws the two of them together then. So it's ironic that the chlorine atom basically steals an electron from the sodium atom, but in the end, they're both happy about this stealing that occurred because now they come together, they share some electrons, and they make salt. Right? So it's a great example of ionic bonding together. So for ionic bonding, opposites attract, right? Just like a snowman in the winter, just like positive and negative magnets, like black and white, like cats and dogs, like, I don't know, balloons and, I don't know, cactuses. That seems weird, right? Opposites attract to each other, just like in the real world, in the atomic world, it's the same thing. Pizza and watermelon. Are they friends or not? I don't know. If you have multiple ones, right? Let's say you have a whole bunch of ions that are all joining together. Well, that's what's called a polyatomic ion. So that would be like you have lots of salts combined together, right? Poly, get it? That would be a polyatomic ion for it. So if you could see the individual atoms in a polyatomic ion, they would look like this, right? They line up negative to positive, negative to positive, negative to positive, right? Positive to negative, positive to negative, positive to negative. It becomes kind of like a three-dimensional material, kind of like they're trying to show you in these little pictures right here. So polyatomic ion, it's just an ionic bond, but happening many, many, many times over and over and over again. So you have, a substance like salt or something like that. That brings us to the joke of the day. Why does everyone find me so attractive? My magnetic personality. Yes, magnetism. It's what's holding those atoms together. Ionic compound is just like the polyatomic ions, but now there are so many millions, billions, trillions of them combined together that it's a compound. It's something you and I interact with. So now instead of it just being like a little salt molecule or a couple salt molecules, now we're going to talk about like an entire pile of salt, like a whole salt shaker full of salt kind of thing, right? And it's not just salt. All of these products right here, they're all held together by ionic bonds, right? So you can see there are tons of ionic bonds all around you. Some of the most common things that you know about, like a hot dog, are all held together with ionic bonds, right? Piece of magnesium burning, right? You've all seen magnesium burning because that's what a sparkler is, right? All a sparkler is imagine you've got a metal stick, kind of like my pencil or pen right here, right? They basically dip it in the factory in some glue, then they dip it into some ground up pieces of magnesium, and when you catch it on fire, that bright light kind of sparkling away and everything, that's magnesium burning. That's the chemical reaction that's happening, right? But that reaction of magnesium or a sparkler burning, that's an ionic reaction happening for it, right? Or you could get this joke right here, right? You've got two atoms talking. One atom says, "I'm about to lose an electron," and the other one says, "Are you sure?" And then he says, "I'm positive." Get it? If the atom loses an electron, right? It loses one part of its negativity, so it becomes positively charged. Let me show you, there's a short little video here talking about this. That's kind of interesting for you to see.
The periodic table lists all the substances in the universe that have only one type of atom in their makeup. Countless millions of other substances are made from combinations of these atoms. When atoms come together, they form bonds, and the resulting molecule or compound has a whole new set of chemical and physical properties. So let's look at chemical bonding and start with the most abundant atom in the universe, hydrogen. The element hydrogen has one proton and one electron, making it quite simple. The proton is positively charged in the center of the atom, and the electron is negatively charged and occupies a larger space outside the nucleus in the form of an electron cloud. This electron cloud surrounding hydrogen is often called an orbital. It is basically all the places where an electron has a chance to be found. Now let's bring another hydrogen atom into the picture. As we slowly start moving them closer to one another, we will show their combined energy on this graph. For a while, nothing changes. And then as they get close enough together, their energy starts to drop and eventually hits a minimum. And this makes the combination stable. This minimum energy distance between them is called a bond distance. And they are now sharing electrons. This is called a covalent bond. And instead of having two individual hydrogen atoms, we now have an H2 molecule. Moving the atoms any closer increases the energy greatly, since the positive protons in each of the atoms are repelling one another strongly. Covalent bonds come in different lengths and strengths depending on the atoms involved. These bonds are often shown as posts, lines, or dots between atoms. But of course, these are simply representations of places where electrons spend their time between atoms. In a covalent bond, electrons are shared, but they aren't necessarily shared equally. Let's take one of the hydrogen atoms and replace it with a fluorine atom. Watch what happens to the electrons throughout the atom. Fluorine, by its very nature, has a stronger pull on electrons in this molecule than does hydrogen. Fluorine shares electrons, but not equally. Instead, it pulls electrons closer to itself than to hydrogen. This is called a polar covalent bond. Each element in the periodic table has a tendency to pull electrons towards itself in a bond. This property is called electronegativity. When you alter the periodic table to show electronegativity, it looks a little different. Notice that elements on the left-hand side of the table, metals, have very low electronegativity values. They don't pull electrons towards themselves at all. As a matter of fact, they willingly give them up entirely. Table salt, as we know, is made up of sodium and chlorine, and so it is called sodium chloride. In forming table salt, the sodium atom gives up an electron and becomes positively charged. The chlorine atom picks up the electron since it is more electronegative and becomes more negatively charged. Now a very old saying takes over. Opposites attract. So here, the atoms are drawn towards one another by their positive and negative charges. If there are enough atoms, we can eventually wind up with something as big as a single salt grain. This kind of bond is called an ionic bond. It has a very strong attraction between positive and negative ions. Most people differentiate this from a covalent bond by saying that in ionic bonds, electrons are exchanged instead of shared. Ionic bonds are very strong, stronger than covalent bonds. And you can easily see this difference. Melting sugar, which is breaking a covalent bond, is simple and makes caramel. Melting table salt is very different and requires temperatures higher than 1400 degrees Fahrenheit. Ionic bonds are very stable bonds. Very important, and much weaker than ionic or covalent, is a hydrogen bond. When hydrogen atoms connect to a small, strongly electronegative atom like fluorine, oxygen, or nitrogen, the resulting molecule pulls the electrons so strongly to the larger atom that the hydrogen nucleus, its one proton, is essentially exposed on one side. So it will bond to the negative side of any similar polar molecules. This bond is called hydrogen bond. The difference in strength of the different types of bonds is fundamental to allowing the DNA molecule to replicate itself. The bonds that hold the opposite sides of the double helix together, the A's and the C's and the G's and the T's, are hydrogen bonds and are very weak compared to the bonds that hold each letter to the backbone and the bonds that hold the backbone together. This allows the molecule to unzip easily, to expose one side as a template for replication. Life is all about bonds. Bonds. Chemical bonds. Who knew?
All right, so there you go. That's going to talk about some of those chemical bonds, the different kinds. Today we're focusing on ionic bonds, but we will get into the polar and covalent bonds fairly quickly. Last thing for today, right? There is a worksheet that normally we do, and we normally just go over this together anyway. Some of these questions are the ones that are going to be on that quiz that you're going to take after this video. So, question number 1, what kind of ion is this one right here, sodium with -3? That one's going to be polyatomic over here. Question number 2, an ion is formed when an atom gains or loses what? Well, we've been talking in this whole chapter about atoms losing and gaining electrons, right? Number 3, an atom that loses 2 electrons becomes an ion, right? Because it doesn't have the same number of electrons as protons anymore. With what charge? Well, if it loses 2 electrons, it's going to have a +2 charge. An ionic bond is an attraction between, well, 2 charges that are opposite from each other. Right? Ions are made of more than one atom. These are examples of polyatomic ions, right? Poly means more than one. When sodium combines with chlorine atom, making salt, right? The ionic bond of the sodium atom is, right, it's going to lose that 1 electron. That was in that short little video that I showed you where the sodium loses, or sodium picks up the 1 little tiny electron that's right there. And then, where is it? Number 7, atoms would rather be chemically stable or electrically balanced. Well, this one, it's a trick question right here, right? If it says the word atom, right, an atom by definition means that it already is electrically balanced, right? If you say you have an atom of, let's say, any element on the entire periodic table, right, it's saying you have the same number of protons, neutrons, and electrons in it. So it's already electrically balanced, so that one's just going to be true for that one question. All right, make sure you take the quiz after this, and I'll see you in class.